All right, so over the next week, we're going to be looking at math traps. Math traps, we need to understand, are very much present on the ACT. They're trying to trick you. The ACT is kind of a jerk. It's trying to trick you into answering the wrong question in a way. It's asking a question kind of misleadingly on purpose. So what we're going to look at is 6 different ideas this week, and then we'll sprinkle some more throughout after that. So first one up is percent of a percent. So main idea here, the trap is that you can't add or subtract percentages like you want to. The way to do it is apply one percentage at a time. And the big trick here is that if they don't give you a starting value, you want to choose 100. Since we're talking percent, that means out of 100. So we'll want to use 100 as our starting value. So as we all know, Chipotle has had some issues lately. Because of these issues, Chipotle stock lost 15% of its original value. Then Chipotle announced they were going to do some cleanup, shut down for a lunchtime at every single store. So they regained 15% of their value. Now here's the trouble. It is not 115 because it doesn't say that it rose 15% from its original value. It's not even 100%. If you lose 15% and then you gain 15% back, that second 15% off is off of your reassessed value. So let's look at how that works. So if we lose 15% of our original value, that puts us down to 85%, or the number 85. If I regain 15% of 85, I don't gain 15 back. It's 15% of 85, not 15% of 100, which is why 100% is definitely not our answer. So I'm going to multiply those two, and that is 12.75. What am I going to do with that? That's how much I gained back. So let's add that to the 85 we were at. And that's where 97.75 comes from. So be very careful when dealing with percentages. Realize that you need to assess the first percentage and then figure out what percent of that new number is going to be added or subtracted. The next trap we're going to talk about today is weighted averages. Much like percentages, you can't just add average to other averages. That's kind of the trap here. The proper way to do it is to find the total value over the total trials. So the trick here is to recognize when you're going to use this. The data is going to kind of change with each problem. So it could be questions about tests. It could be questions about percentages, actually, kind of hidden in there, especially with tests as the potential question. Or how about this one with sports? So Steve averaged 2 goals a game over 3 games, and then really went off and averaged 4 goals a game for 2 games. How many goals did Steve average over the total 5 games? So what's very tempting here is to just say, well, 2 averaged with 4 is going to be 3, so my answer is C, 3 goals. And that's not going to work because Steve did score 2 goals over 3 games and 4 goals only over 2. So it's not an even split. If it were 3 games and 3 games, we could probably do that. But since it's a different number of games, the weight is different. It's weighted more toward 2. He scored 2 more often than he did 4. So that also means D and E are also kicked out. So now I have it down to A and B since he scored less for more games. So what we're going to do is we're going to take 2 times 3, so 2 goals over 3 games, plus 4 goals over 2, for a total of 5 games, and figure that out. So 6 plus 8 over 5 is 14 over 5, which is 2.8. And the last trap topic for today is average rates. Average rates look kind of like an easy problem, but turns out to be very similar to the weighted average problem. Difference is that with a weighted average, they kind of break everything down. It said, like, for example, in the last one, he scored 2 goals over 3 games. Difference here is that with an average rate, it's already going to be reduced. So something like miles per hour, which we'll see in a second, is a great example of an average rate problem. I can't just average the 2 values. I need to find the totals for the numerator and denominator. Then we're going to divide. So the trick here is that I choose a value that is common for both numerators. So that's a little bit different. I'm actually looking for the least common multiple for the numerators. I'll show you what I mean. So you're driving home through traffic, or you're driving to work, excuse me, at 40 miles an hour, and you're heading through traffic, so on the way home, there is less traffic, and you can drive at 60 miles an hour. What was your average speed? So most tempting answer is to say 50. You answer that, you move on with your life, but you're wrong. You can't just average the two, and here's why. Do you agree that the distance from home to work and then work to home is the same? Yes, unless you're living in a different dimension, I'm pretty sure that's true. So if I drive 40 miles an hour to work, I'm actually spending more time on the road at 40 miles an hour. Where on the way home, I'm spending less time and it's at 60 miles an hour. So that means I'm actually out on the road slower, longer. So that also means 52 and 58 can't be correct either because I'm driving the more time at 40 miles an hour instead of 60. So I'm actually going closer to 40. Let's see about that common numerator. So I've got 40 miles for 1 hour and 60 miles for 1 hour. And I want a common numerator. Here's why. My distance from home to work is the same as work to home. And distance is my top value here. They're both miles. So let's make both of them the same. And my least common multiple for 60 and 40 is 120. So I'm going to rewrite 40 miles per hour as a 120 miles per, and that would end up being 3 hours. And 60 now becomes 120 as well because we want the same distance between our home and work as work to home, and that would be over 2 hours. So adding those two together, that gives me 240 miles over 5. That goes in nice and evenly. Looks like 48. So it is 48 miles an hour that I'm actually going, so find a common numerator, add the numerator and denominator together, then divide, and you'll have your answer.